Complete the table below for the ions listed. You may need to use www.webelements.com. So in the first column, you want to list whether it's a cation or an anion. In the second column, the number of protons. You can skip the number of neutrons, and then the last column is number of electrons. Good. So anytime you see a negative charge, that means it's an anion. So O2 minus would be an anion. Cl minus would be an anion. Now if you see a plus sign, that's a cation. So Na plus is a cation. Mg2 plus is a cation. Now if you look at the number on the periodic table above oxygen, you'll see the number 8. That's the number of protons. Same thing with sodium. Look at the number on the periodic table that appears above it. You'll see 11. For chlorine, you'll see a 17 above it. That means there's 17 protons. And for magnesium, you'll see a 12. That means there's 12 protons. To get the number of electrons, if you don't see a charge, so if there's no positive or negative, it's the same as the number of protons. But these all have positives and negatives. So what you want to do, so to get the electrons, do the protons minus the charge. So 8 minus negative 2, that's a double negative here, so you end up doing 8 plus 2 gives you 10. Number of protons is 11 minus positive 1. 11 minus 1 gives you 10. Here you do number of protons 17 minus negative 1 gives you 18. And 12 minus positive 2 gives you 10. This is a really good graphic organizer. So electrically neutral atoms lose electrons to become cations. They have an overall positive charge. Electrically neutral atoms gain electrons and become anions. And then this should say they have an overall negative charge, not positive. There's a typo there. So that should say negative. Okay, for this chart right here, there are 4 isotopes of strontium. Remember, isotopes have the same number of protons, but a different number of neutrons. So these numbers should all be different under your neutrons column. So let's fill in the chart. So put in the number of protons, number of neutrons, and number of electrons for each of these. Good, so strontium is always going to have the same number of protons no matter what, so that is 38. You can find that number by looking on the periodic table at the number that appears above strontium. It should be a 38. Since these are all electrically neutral, you don't see any pluses or minuses, they're going to have 38 electrons as well. Now to find the number of number of neutrons, what you want to do is do the mass, which is this number listed right after strontium, and subtract the number of protons. So 84 minus 38 gives you 46. 86 minus 38 gives you 48. 87 minus 38 gives you 49. And 88 minus 38 gives you 50. In the atom below, point to the electrons that have the most energy. So those are going to be any of these outermost electrons right here. So you could have pointed to any of these. So outermost electrons have the most energy. In the atom below, point to the electrons that have the least energy. So those are the electrons that are on the inside that have the least amount of energy. So either of these. In the atom below, point to the valence electrons. So the valence electrons are the ones that are on the outside. So the outermost electrons are the valence electrons. Draw an arrow to show what would happen to the green electron if it gains energy from the environment. So what's going to happen to this electron right here? Is it going to move here? Or is it going to move closer to the nucleus? So is it going to move farther from the nucleus or closer to the nucleus? This electron will move farther from the nucleus. Nice job, because if it's gaining energy, it needs to go to a higher energy orbital. So this outer orbital is higher in energy than the inner orbital. So if it gains energy, the electron will move to an outer orbital. Draw an arrow to show what would happen to the green electron if it loses energy from the environment. So what will happen to the same electron if it loses energy? So if this electron loses energy, it's going to move closer to the nucleus. So it's going to move down in an orbital. What is the maximum amount of electrons each orbital can hold? So for an s orbital, a p orbital, and a d orbital, what's the maximum amount of electrons it can hold? An s orbital can hold 2 electrons, a p orbital can hold 6 electrons, and a d orbital can hold 10 electrons. And if you look here, like here's an s orbital, it has 1 box. Each box can hold 2 electrons. P's have 3 boxes, each with 2 electrons, that gives you 6, and D's have 5 boxes. So 5 times 2 gives you the 10. An electrically neutral atom has the following electron configuration: 1s2, 2s2, 2p6, 3s2. What is the name of this atom? And you can use the periodic table to help you with this. Or if you're stuck, you can answer these questions as well. How many electrons? How many protons? What is the atomic number? So these are 2 things you can use. You don't have to use both of them to get the answer. So the 2 ways you can do this, you can just go through the periodic table. So start out 1s. So this is 1s, it's the first row. And there's 2, so 1, 2. Then you have 2s2, so here's the second row. S1, 2. 2p6, 1, 2, 3, 4, 5, 6. And then 3s2, and you'll get to magnesium. Or you can look at how many electrons. To find the number of electrons, you just add the small numbers up here. So 2 plus 2 plus 6 plus 2. 2 and 2 is 4, plus 6 is 10, plus 2 is 12. So if you look at the number above magnesium, I know it's hard to see on here, but it's a 12. Let me move that down. There, you can see it now. So it's a 12. So that would be magnesium. In determining the electron configuration for an electrically neutral atom of oxygen, number 1, what is the atomic number for oxygen? Number 2, how many protons does it have? Number 3, assuming it's electrically neutral, how many electrons does it have? Number 4, fill the orbital diagram according to the roles. And number 5, write the electron configuration. So the atomic number for oxygen is 8. That's the number that you see up here above oxygen. It has 8 protons. Atomic number is the number of protons, so these are exactly the same. As long as it's electrically neutral, that means it has the same number of protons as it does electrons, so it'll also have 8 electrons. And then you just fill those electrons into this orbital diagram right here. So start in the 1s, the box can hold 2, so there's 1, 2, then 2s can hold 2, then 2p can hold 4. And actually, this does not look good. Remember that each box needs to have 1 before any box can have 2, so it should look like that. So 1, 2, 3, 4, 5, 6, 7, 8. Now write the electron configuration. You can just use the boxes. So do 1s, there's 2 in there, so that's where the 1s2 comes from. Then 2s2, and then 2p, 1, 2, 3, 4. So that's how you write the electron configuration for oxygen. All right, electron A falls from energy level X to energy level Y and releases green light. Electron B falls from energy level Y to energy level Z and releases red light. Which electron, A or B, experiences a greater change in energy? Explain. So here's green light. Here's red light. There's more energy on the left, less energy on the right. Yeah, good. So electron A is going to, because it is releasing green light, which is higher in energy than red. So if you release green light, that means you're releasing more energy than if you release red light. All right, nice job. This ends the Unit 2 review. Tomorrow we will do the Unit 3 review. I hope you guys found that helpful, and I hope you did well when answering the questions. Thank you for your time and attention.